of chapter 3. But this is a problem from Ashton here. I've got y equals x minus x squared quantity squared. Oh, is this the one I did the other day, or no? No, it's not, right? Because I have a -2 power. This was not on my review. This was not on that test, was it, Ashton? No. But I got the problem correct? Yes. So I have two choices here, product rule or quotient rule. I'm going to do the product rule, okay? So my first function is x minus x squared quantity squared. The derivative is 2 times the x minus x squared quantity, that quantity, times another 1 minus 2x, right? Derivative of the inside. And my other one is my next function is a 1 minus 2x to the -2 power. Bring down the power, reduce the power by 1, and then take the derivative of the inside, which is another -2. So far, it's looking good. I need this product, right? I need that loop for the product rule. So y prime is 2 times x minus x squared, that quantity times 1 minus 2x, plus 4, right? So now I'm combining things here. There's my +4 times an x minus x squared quantity squared times a 1 minus 2x quantity to the -3rd. So if you can see, I can take out one of these, right? Yes? And I can take out -3 of, right? 3 of those, right? I'm taking out, so there's a power of 1 here. Which is smaller, 1 or -3? The -3 is smaller, that's what I'm taking out. I can take out the smaller factor of the, right, of the smaller exponent, sorry. So it looks like I can take out a 2, I can take out an x minus x squared, and I can take out a 1 minus 2x to the -3. The tricky part is now what's left over, right? And I think that's your issue, is you never had that to the -3rd power there on that paper. Okay, so what's left over? Well, the 2 is taken care of, right? The x minus, all right, so there's how many powers of 1 minus 2x left? How many? 4? Yes, 4. Oh, that's horrible. Plus 2 times x minus x squared. Kind of nasty. Sorry. I don't know where you got this problem. Is it on one of my old tests? No. Where'd you find it? Where? Okay. Yeah, it's pretty nasty, but that's okay. Doesn't mean we can't do it. So I right away see I can take out an x from here, and I can move my 1 minus 2x to the third. That I can move that downstairs, and then this is just going to take me some work. I'd rather do the FOIL pieces, right? So I'm going to FOIL each of those and then then distribute it again. So it's kind of horrible. So here I get 1 minus 4x plus 4x squared times itself. And it's just horrible, right? But what can I do? I got nothing else to do, so why not finish it? So I've got a 1, I've got a minus 4x, I've got a 4x squared, I've got another minus 4x, I've got a positive 16x squared, I have a negative 16x cubed, 4x squared, a minus 16x cubed, a plus 16x to the fourth, plus a 2x minus a 2x squared. And you see what I mean about trying to save paper. I'm getting myself in trouble here trying to squeeze things in. I don't want to be doing that, right? So now I'm just going to try and get a combination, right? Combine like terms and see what happens. So it looks like I have a 16x to the fourth. I have minus 16x cubed, another minus 16x cubed, so that's minus 32x cubed. X squared, so minus 2x squared, 14x squared, 18x squared. Oh, did I miss one? I missed one, right? Minus 2x squared, plus 2x squared, plus 18x squared, plus 22x squared, sorry. Now my x terms, 2x minus 8, so minus 6x, and then my constants is just 1. Pretty nasty trying to figure out if this thing factors or not. But if you remember from pre-calculus, I could take that, graph it, and see if it even hits the x-axis at all, right? Does that make sense? Let me just show you what I'm talking about. I'm not going to give you one like this, where you'd have to, where that would be possibly an impossible thing to graph. But I'm going to Desmos. And I'm doing y equals 16x to the fourth minus 32x cubed plus 22x squared minus 6x plus 1. Nice, and it doesn't factor, right? Do you see? It doesn't factor. It doesn't hit the x-axis. It can't factor. So it's done. That's my final answer there. I think this is slightly more difficult than what you could expect, just because of this horrible thing. Anything else you want me to do? Well, good morning. Let's see, who is here? Callista's not here. Sebastian not here. Daniel is here. Ethan is here. Hosma's here. Max is here. Dogum is here. Lana's not here. Watt is here. Ashton, Matt McGill is not. David is not. Michael is not. Michael's not here yet, right? No. Laura, you here yet? Nope. What's going on? Sonia's here. Kelvin's here. Sheila, Autumn's here. DeWitt's not here. Elderwood's here. Jarrell's here. Nice. Good. So what's on our quiz Friday? Right? I uh, like for sure, I'm going to put a chain rule problem on, right? One or two. Like if I thought about it right now, it would be tangent line, right? So I'll say f of x is equal to x square roots of 1 minus 2x. So I need a derivative to get the tangent line there. So that's a product rule, and if you look at the inside, you can see it's also, morning, you can see it's also a chain rule. Remember, you're always thinking chain rule from now on. Should we try this one? Morning, Michael. So let's do a tangent line at x equals -4. Dogum, you're adding in your Desmos to it because you've already attempted, right? Okay, tangent line at x equals -4. So what do I need? I need a y value, I need a derivative, I need a slope, I need the tangent line, right? Sebastian, morning. We just did one problem with the product rule, chain rule. I recorded it, and now we're doing a tangent line. So that first problem that Ashton had me do, it's like that, but easier, okay? One like that on the quiz on Friday, but easier. And if you can give me your homework for Friday so I can update grades for Monday to give a midterm grade. The quiz will help your midterm grade. Handing in homework will help your midterm grade, right? It's still not a fair grade, okay? But it doesn't mean anything. If you're passing, great. If you're not passing, let's get to work, right? It's that simple. Who got the y value already? Any agreement there? Thank you. So derivative, yes? When they get there for the derivative? I could imagine that you have your derivative and you stop here, right? You see that anybody get to here for your derivative and then stop there? No? So but the key is, right, if you have more than one fraction, you want to make it single fraction completely factored. Right? No, I just got an LCD. So looking in the black here, you're okay with my loop? The loop, it's product rule loop. Yeah, is that okay? So once I get here in black, right, I see that I have an LCD of this, so I multiply the piece that's missing the LCD by the LCD over itself. Okay, so now everybody has the same downstairs, but upstairs is 1 minus 2x minus x. Right, does that make sense? It kind of looks like a conjugate, but it's not. Nice. Yes. Cosma? Yeah. Let me put numbers on in case, okay? You want a picture, I can zoom bigger and do it. If you want, okay? Michael, question? Yeah, so remember, I'm giving you a function in the next value. You need to find a y value, I need a point. I need a derivative that gives me the slope. Yeah, it depends on what my function looks like, what to do, right? Yeah. And then once I have my derivative, I plug in my x value to get my slope, right? So now I have my slope and my point, right? I have point of -4, -12, and then I put everything in to get my tangent. Remember, you can go right to Desmos here and make sure it's right before you go do the algebra to get me here, right? So there's two problems on the quiz. plan on getting 4. So I thought I would give one more limit, 3 minutes, and have you verify the quotient rule, and then maybe another trig. You want to see my trig question I would give you now, if I were to do it now? Yes? So I want to make sure everyone's okay here before I move on. Is this okay? Delaware, yes, okay? Yes? Daniel, you nice? Kelvin, yes, you okay? I'm not in a rush, so I don't have to move on until you're ready for me to move on.
So
Yeah, go ahead, Kelvin, where?
when we do the product rule,
Yes,
so it's the x times the square root.
that's right. So my first function is x, right? My second function is square root of, right?
Yeah.
You see that?
So f is the first
X, the derivative is 1. Second function is a square root, so the derivative is 1 over 2 square roots, right? But then times what's the derivative of the inside? Negative 2.
because we're using the final derivative, we're always using
Always chain rule, exactly. Okay? Good. Let's do a problem with the trigs. And this was one that was on a previous, I think I even put it on something for you already, where I asked you to do I can't remember now. Maybe it was another class. So here we go. So I could imagine myself putting something on like f of x is sine x times cos x. And I want a tangent line at, let's say, 2 pi over 3. So again, here I need a product rule for my derivative, right? I need to find the y value, I need to find a slope, I need to find a tangent line. Good, on your mark, get set, go. Yes. I think I gave this one before, right? But I think I gave you the derivative on the quiz. Yes, Autumn, you got it? So where are you here? Oh, in Desmos? Oh, I go to the gear, I go to the wrench in the top corner here, and then I set my step in the X by pi over 3. I picked pi over 3 because I gave you a 2 pi over 3, right? So stepping by pi over 3 makes it a little easier. So it then changes it's like on your calculator you might have done in the past zoom trig, and it will turn all your axes into pi values instead of right 1, 2, 3, 4 instead of. Not too bad, right? For this quiz, we're going to do better on this quiz, right? We're going to get all of the old chapter 3 exams and all of the midterm exams done for next Friday, right? Next Friday is our test. I will be giving you a midterm before that test, a midterm grade, just because the school is going to make me do that. If you're passing, great. Don't worry about it. If you're not passing, let's just get to work. Yeah, Daniel. Yes. So I would imagine me just doing the product rule here is not the issue. I think the issue is knowing the identity, right? So, but first function is sine, derivative is cosine. Second function is cosine, derivative is negative sine. And when I'm doing the product rule, I definitely need this piece and this piece, right? And I pick the positive one first. I tend to do that. Instead of me writing negative this plus this, I write something minus something. So I write one less SIGN, one less plus sign. But if you got to here and you got the correct slope, great, right? It still should give you the same slope, but you should have those trig identities down, right, on your formula sheet. Double angle, half angle, sum and difference, Pythagorean, all of the ones you learned in pre-cal. Yeah, Michael. Say again? Yeah, here. Okay, but I did too. My negative I just pushed out there. Yeah. Go ahead, Kelvin, what were you saying? Oh. What did I do? Oh, I was supposed to just put pi over 3, you're right. But I got lucky. I was supposed to put pi over 3, right? So 1, 2, 3, 4 pi over 3. It's still cosine's still negative there. I got lucky. Thank you for seeing that. Autumn, what you're saying? Yeah, yes, yeah. Yeah, I mean, it's kind of exactly. Morning, Laura. Yes. Probably that weird one there that I'm skipping steps on is when I do this times this, the 2's cancel. So positive pi over 3. And then I got an LCD, right? Again, I'm skipping steps there. You don't have to skip the steps if you don't want to. But I'm getting my LCD of 12. Nice. I think we're ready for the quiz. Let's take a look at the last section of chapter 3 that we're doing. Okay, is that okay with everybody? Do we need any help to deal with? Any help? You okay? Yes, Michael. Yeah. So when I remember, it's a product rule. So first function is sine, derivative is cosine. Second function is cosine, derivative is negative sine, and then I'm using that loop. So I need the sine times the sine squared. Right? You see it? And then this is an identity that we learned in pre-cal. I didn't have to use the identity to get the correct slope, right? Right? We agree with that? I could get the right slope without knowing the identity, but if you can get to elegant, right? Nice. So we're looking at section 3.7 here. And we have one new shortcut to add to our list. If y equals the ln of u, y prime is u prime over u. So very simple. So the last couple of pieces that we've done, we've created a new formula where we almost don't have to think about the chain rule. We don't have to think about what's happening when we're doing our derivatives. So if you remember, I had y equals arc sine of u, right? Gave us y prime is u prime over the square root of 1 minus u squared. So, and then I asked you, what do you have to do? What's my little checklist here? Find u prime, right? Find u squared, plug and chug, right? Yes? So it's the same thing here with our new formula, but a shorter list. What do I have to do? Find u prime, plug and chug, right? So let's look at a couple of problems. So this is our last shortcut for a little bit until we start doing antiderivatives. Then we're going to have a list of antiderivative shortcuts, meaning undoing the derivative, taking a derivative and getting back to the original function. All right, so let me open our book here. I am recording this, so if you came in late, I recorded 4 problems that are going to be similar to your quiz, okay, on Friday. So there's a couple of interesting little properties with this ln derivative. And if you see them on my old test, they'll say, get the derivative using an ln or using the ln trick, okay? So let me just do a few problems and then eventually we'll get to one with the ln trick, okay? If you remember me saying last time, I am not using anything but base E, okay? So you'll see in these problems, you'll see base 2 or log, or just log base 10, right? So, but I am going to restrict it just to the ln function or base E, okay? So let me do one that's, I guess, not too horrible. Let me do number 5. So this is 3.7, number 5. And I think I gave you suggested problems from 3.7, did I? I gave you suggested problems from 3.5, 3.6, 3.7. Yeah. So f of x is the ln of the sine squared of x. Sine squared of x is a really good one for me to give you on the quiz Friday. So we better make sure we know how to do that. Let's just work on that on the side first. If y equals sine squared x, what's the outside function here? No, just on my right-hand side here. We're just working on this on the side. Yeah. What's the outside function? X squared, the squaring function, right? It would be easier to see it if I wrote it like this, where you could clearly see the inside function is sine x, right? You with me there? Good, so what's y prime now? 2 times the inside, right? But now to the first power, right? And what am I keeping inside the box? Whatever I had originally, right? So 2 times the sine of x, but now I need times the derivative of the inside, which is cos x, and then we recognize that as sine 2x, right? Another identity. If you look at my old quizzes and old tests from chapter 3, you'll see this function on there. In fact, you'll see this one too. Y equals sine squared of 2x. Now the inside is sine squared of 2x. Sorry, sine of 2x, right? But that has an inside too, right? So what's my derivative here? 2 times what? Good. And the inside is sine of 2x, so derivative of sine is cos of 2x, but there's another inside, so times 2. And so you should see that I have now 2 times the sine of 4x. Who's confused by that one? It is, it's the same identity. So 2 sine theta cos theta is 2 sine twice theta. Right? Sorry, 2 sine theta cos theta is sine of twice theta. And then I have an extra 2. Well, what? Say that again?
You said you have the extra 2. Don't you just multiply that in?
No, it won't be. It's a little weird because for this 2 to apply again, I would need a sine 4x cos 4x. For me to use that identity, right?
I wasn't saying using the identity, but so the 2 sine, okay, so 2 sine 2x times 2
is sine 4x.
Sine.
Double the angle.
Okay, that's where the, got it.
Yes.
My brain
Double the angle, right?
The 2 wasn't there from that.
Exactly.
That's the same.
Exactly. All right, let's go back to our problem here now.
I don't get the
Of what? Of this one?
The bottom.
Okay, so, but y equals sine of 2x all squared. All right, so clearly we see the outside function is x squared, right? Outside function is something squared, right? So to get my derivative, I bring the 2 down, keep whatever's inside, but now it's not to the second power, it's to the first power. Done, right? But I have to then, and this is times here, I have to then say, what's the derivative of that inside function? Well, the inside function was sine. So derivative is cosine. Keep the mouse that's inside the cat, and then say, what's the derivative of that inside? Here's my other 2. They're tricky. They're tricky. You got to sit there with them for a little bit. Michael, yes. Yes, so this is my identity. If I have 2 times sine theta times cos theta, that's an identity of sine double theta. So my original theta was 2x, so when I double it, I get 4. They're tricky. I would put it on my formula sheet, honestly. If you're going, I have no idea what the hell's going on, put it on your formula sheet. Do a little Desmos investigation, right? Yes, you know what I mean? So Desmos investigation. Y equals sine squared x, right? Yes, you with me? Notice it looks like sine, but everything's positive now, right? It's also a little bit steeper than regular sine. Maybe not, nope. Okay, but anyway, my investigation should be, I gotta call the first one f of x. And now I can have Desmos do my y equals f prime. And then put in my y equals, what did I get? Sine 2 theta, right? Sine 2x. And I'm going to hide my original function and then make sure my other ones are matching, right? So I'm showing that I got the derivative right. So you need to sit there and do it again anyway. Go look at all my old tests. Go look at all my old quizzes. Go look at my midterms. Make sure you do every one. Yes, it's a lot of work. What else you got to do? This is your job. You're going to get through college in 3 or 4 more years, and then you're going to make $100,000 a year. And you won't mind the pain then. If you go for your master's, you'll make that much easy. Okay. Back to my problem. Ready? Here's my original problem. This is the one I want to work on. I have the formula y equals the ln of u gives me y prime equals u prime over u. So what do I have to find? U. I got to find me. You got to find you. So I know it's over sine squared x, but what's the top part? What did we get as our derivative over here? Remember, I need u prime. What did we get as our derivative? Sine 2x, right? But it looks like if I don't use the identity version, I might get something a little bit nicer. If I use it as 2 sine x cos x over my sine squared x, you see I get 2 cos x over sine x, right? 1 sine x cancels, and that's what? Cotangent, right? Cosine over sine is cotangent. Sine over cosine is tangent, yes? Let's do another one from the book, okay? This is number 13. Is this okay? 13, can I move on to 13? I've got y equals the ln of x plus square roots of x squared minus 1. Yuck. But what do I know? I know right away I need that inside prime over the inside. Yes? It's that easy. These derivatives are that easy, okay? But you can't fight it. You can't fight that I have given you a formula just to plug into. And you know where we got it from. We got it from implicit differentiation. I did that on Monday. So you have to trust it. You have to trust that it's so easy that all I have to do is find u prime, and then plug things in, right? Say again? Yes. No, it's not. It's counterintuitive. I agree. I know. It's crazy. Good. So what happens upstairs? Derivative upstairs is 1 plus 1 over 2 square roots of x squared minus 1 times another 2x. Everybody okay here? Make sure everybody's okay here. I want some kind of nod or some kind of grunt, some kind of noise. Good. I can simplify this. I have 1 plus x over square roots of x squared minus 1 over x plus square roots of x squared minus 1. What do you think? Am I done? Is that the answer in the book? No. How do I know it's not the answer in the book? Because I have fractions within fractions. So I'm going to clear with an LCD of x squared minus 1 over itself. Now, upstairs, I have what? Square root of x squared minus 1 plus x all over x square roots of x squared minus 1 plus x squared minus 1. Ugh. Debatable on whether this is better or not. I'm just taking interior denominators, right? When I have fractions within fractions, take interior denominators. This one's kind of ugly. I'm kind of interested in this answer. Let me cheat. Let me go to the textbook. So when I go to Blackboard and Blackboard first opens, you can create favorites and they'll pop up right away if you want to do that. I just go to courses, and in the top left corner here you'll see this semester 202320. Don't ask me what's going on with that number, but that's it. And then I'm looking at our class and homework solutions, right? Yes, you know they're here, right? And we're going to chapter 3, and I want to go to 3.7, number 13, and see what they have. Too far. Oh my God, look at what they have. So I know I have to do more work, right? I know I have to do more work. Let me rethink what I did. It's probably a conjugate. It's probably a conjugate. Let me try that, okay? You with me? I want to go back to here and try a conjugate and see what happens first. Okay? But this is a part of the process, is checking your work and saying, hey, did I get the algebra they wanted me to get? Clearly I did not. So I got to rethink, right? Yeah, so let me go back to here. Y prime is don't write anything yet. Wait, let me try it. If you want to try something as well, that's fine. But I'm going to try this conjugate downstairs in hopes of getting rid of that radical downstairs. Right? So I'm going to do x minus square roots of x squared minus 1. Right? I'm not going to touch the upstairs. I might have to, and I'm pretty sure I do, but I want to at least see that my downstairs now becomes x squared plus x squared minus 1, at least, oh, sorry, minus, right? So you see the x squareds are going to cancel, and I'm just going to get a denominator of 1. That's kind of nice, right? Because now look at what I have. Now, yes, now I think I could get rid of those interior fractions, and that should do it. So that's what I have now, much better than what I had a second ago. I could try and FOIL and then clear fractions, or I could try and clear fractions. I think either will work. So I will FOIL. I don't know. I'm lost. you, oh, minus x. Thank you. That helps. That helps. Right? Nice. I wasn't lost. I just needed help. Now I clearly have a downstairs of x squared, square root of x squared minus 1. And upstairs becomes x squared minus x squared minus 1. There it is. Woohoo! Thank you. Thanks for the help. That's what we need sometimes. Try something, right? Yeah, so these two guys cancel, right? Yep. Yep. Okay, let's do one with the ln trick. Last problem today. So I'm going to the textbook, and I'm looking at number... Where's the one I want? Well, I might as well just do something like 38, okay? Because that involves the ln trick. So this is number 38. So I have the function y equals the tan of x raised to the 1 over x. But the problem is, this is a function raised to a function. We have not dealt with that yet. We've had a function times a function divided by a function, right? but we have not yet had a function raised to a function. So what we're going to do is take the ln of both sides. And I will tell you on your test to take the ln of both sides or use the ln trick. That's my shortcut way of saying that. So we're going to take the ln of both sides, and we're going to remember from our pre-calc class, right, what happens to the exponent inside of the argument of ln. It comes out as a multiplier, right? So now I have ln of y equals 1 over x times the ln of the tangent of x. You remember that property? If you don't remember the property, go to your pre-cal book or any pre-cal book and look up the properties of log functions. There's 3 that I would really want you to have memorized, maybe more. Let me just write them real quick. The log of a times b is the log of a plus the log of b. Right? You remember seeing that before? And of course, the log of a divided by b is log of a minus log of b. And the thought here is you're saying, oh, when I'm multiplying exponents, when I'm multiplying like bases, I add exponents. When I'm dividing like bases, I subtract exponents. And the last one is log of a to the n is n times log of a. So those are the main 3 that you should know, besides, of course, the inverse operations, right? Log of e to the x is x. E to the log of x, e to the ln of x is x, right? Ln of e to the x is x, and e to the ln of x is x, right? Those are the inverse ones. Again, I only use ln just to simplify things. All right, looking at this derivative now, what am I going to have to do? If I apply this derivative now, right, d dx of ln of y should equal d dx of 1 over x ln of tan of x. What do I have to do here? Do you see it? On the left-hand side, what's my shortcut say? Y prime over y. Derivative of ln is the derivative of the inside over the inside. Derivative, yep, y, if y equals ln of u, y prime is u prime over u. You got to have that on your formula sheet. You got to have it memorized. You got to use it. You got to practice with it. On the other side, though, don't I have a product rule? Right? So I have to think about the product rule over here. I've got 1 over x with a derivative of minus 1 over x squared. And then I've got the ln of the tangent of x, which will give me secant squared x over the tangent of x. Derivative of tangent is secant squared. Inside is tangent, right? So secant squared x over tangent of x. U prime over u. So on the right-hand side, what do I get here? I get x times the secant squared x over tan of x minus 1 over x squared times the ln of tangent of x. I can already tell you this is not what's in the book. Kelvin, question? Nope. This is definitely not what's in the book, right? Because I screwed up. It's 1 over x, right? Thank you. 1 over x, right? Product rule, right? Well, I do know I have to solve for y prime here, right? So I can just multiply both sides by y. I get y over x times secant squared x over tan of x minus y over x squared times the ln of the tan of x. And what is y? Do we know? it's the original problem, right? Tan x raised to the 1 over x, but I want to see if I can do anything with this first. I'm going to cheat. I'm going to go to my solutions. This is number 38, right? Oh, no odds. No evens in the book, sorry. It's okay. I'll leave it for you to try and simplify it. It should simplify. I just don't feel like doing it. What's kind of nice is if you use this ln trick when I give you a problem like I did today. What was the problem I gave you today, Doggone? 5 minus x to the what? Minus, Ozma, you have it on your phone, right? Do you have this one on your phone? What was that first problem I did today on the board? Yes. Doesn't matter. I'll just pretend it's this, okay? But watch what happens if I take the ln of both sides here. What happens on the right there? I get, so ln of a times b is ln of a plus ln of b, right? So I have ln of 5 minus x to the negative third plus ln of 1 minus 2x to the second. And now what happens to each of those powers? They come down as a multiplier. So I get ln of y equals negative 3 times the ln of 5 minus x plus 2 times the ln of 1 minus 2x. Look at that. So much easier to do this derivative now, right? You okay with the properties of the log? Good. So what happens on the left when I do derivatives? I get y prime over y, right? I get negative 3. What's the derivative of 5 minus x? What's the derivative of the inside? Yep, so I get 3 over 5 minus x plus 2 over 2 times what over the inside, right? 2 times a negative 1, sorry, negative 2 over the inside of 1 minus 2x. Look at how much easier that turns out to be the first step. You still have to do all the factoring, okay? But it starts a little bit cleaner. Right? I still have to clean up all those fractions. But say, yep. One second, sorry.